Hello everyone, my name is Terry the Tutor, and you are watching part 3 of the integral calculus practice test that I'm going over. So right now we are on number 21, and if you don't know this already, you can find the practice test on my website, terrythetutor.com. I'm sure there will be a link somewhere. 21. I don't know at what point in time you are watching this video, so I can't say for sure. R over r squared minus 8 dr. Alright. I think what I would do when I was learning is I would, of course, try to factor this. It looks like it could be a difference of squares. But that's not necessary. We can solve this by u substitution. I can say u equals r squared minus 8. Therefore, my du, taking the derivative of both sides, equals 2r dr. I can see that I have an r dr. I'm just missing the 2. So let's put a 2 here to make our du, and let's put a 1/2 on the outside. Now we can rewrite with du and u. So we've got 1/2 the integral of du over u. Well, we know that. We have a formula for that. That is the natural log of u. So we've got 1/2 the natural log of the absolute value of u plus c. And what we can do is we can bring the 1/2 up. We're not going to. I mean, we can, but we're not going to. So we're going to have the natural log 1/2 of the absolute value of r squared minus 8 plus c. Awesome. Let's go on to number 22. 22, we've got the integral of 2 over x ln of x squared dx. This is awfully similar to number 20, where we had 1 over x ln of x. So what I'm going to do is I'm going to try and mimic the technique over there. So the first step is to pull the 2 out by the constant multiple rule. So I've got 2 integral of 1 over x ln x squared dx. And now I'm going to do my u substitution. I've got u equals, let's go ahead and say the natural log of x, ln of x. And du equals 1 over x dx. So I can find my du. I've got 1 over x dx. That fits perfectly. And I've got my u, the ln of x. But this is going to be u squared, because it's the ln of x squared. So let's go ahead and rewrite. You wind up with 2 on the outside, the integral of du over u squared. Let's bring up that u squared. Use our power rule. We've got 2 integral of u to the negative 2 power du. And let's add 1, and we'll divide by that number. So that equals 2 on the outside. And negative 2 plus 1 is negative 1. Divide by negative 1 is just putting a negative sign. So just put a negative sign. U to the negative 1. And then we're going to put plus c. So let's bring this down into the denominator now. So we've got 2 over u plus c. And finally, let's replace with our u. U is ln of x. So we've got 2 over ln of x plus c. Sweet. Moving right along, let's go to number 23. 23, we've got the integral of e to the negative x dx. Well, we have a formula for for e's, and I think it says something like this. The integral of e to the u du is equal to e to the u. So let's go ahead and pick out our u. In this case, the u is always in the exponent, so I'm going to pick the exponent. If u equals, whoops, what am I doing? There it is. If u equals negative x, then du must equal, well, let's see, negative dx. Well, negative 1 dx, which is negative dx. So I've just got to add in a negative sign here, so I can match up with my du, and I'll throw a negative sign there to balance out the equation. So I've now got the negative integral of e to the u du. Following that formula, we're going to have the negative e to the u plus c. I should have put plus c there. And my u is negative x, so it'll be negative e to the negative x plus c, or we can say negative 1 over e to the x to get rid of that negative exponent and bring it down to the denominator, plus c. And we're done. Let's go ahead and try number 24 now. 24, we've got the integral of z minus 3 over z plus 3 dz. Okay. Why don't we just split the numerator on this one? And if you didn't know, you can always split the numerator, but you can never split the denominator. No. Not allowed. So we've got the integral of z over z plus 3 dz minus the integral of 3 z plus 3 dz. Okay, that's not too bad. What I'm going to do for this second integral is I'm going to pull the 3 on out. So you're going to see that. And for this first integral, I'm going to use a u substitution. So for the same problem, I have to do 2 different techniques. I'm going to be using 2 different rules. For this problem, it's going to be a u sub, and well, you'll just see what we're going to do for this one. So for this one, let's say u equals, let's use the denominator, z plus 3. So du must equal, oh, that's not going to work. That's just going to be dz. What did I do? Alright, after staring at that problem for long enough, I finally realized what it was we needed to do. It's something we haven't had to do yet. It's called long division. Yes, you can be put in a situation where you have to do long division on your test. The reason being is because u substitution, as you saw, didn't work if I set u equals z, du equals dz, or z plus 3. It's still dz, and it doesn't work out because that z being there messes up the u sub. But if we do some long division, we can change the way it's written and integrate it pretty nicely. So let's say z plus 3 divided by z. Alright, so z plus 3 goes into z. Actually, all you're looking at is the first term, the leading term. Z to the first goes into z to the first one time. So I wind up with z, well, we got to multiply z plus 3 times 1, and that gives you z plus 3, and then we have to subtract them. So let's put it in parentheses, subtract. If I distribute this negative sign, I get negative z, plus z is 0, and negative 3 is going to be what remains. So it's just going to be 0 minus 3. And so that's our remainder. Negative 3 is the remainder. So we can just say negative 3 over z plus 3. That's how you write your remainder. You write whatever is left. Once this number no longer goes into this number, the thing that you're dividing by, then you can just write it as a fraction, the remainder over the divisor, I think that's called. So this is what we have now. This is our new integral. So let's move down. We've got the integral of 1 dz minus the integral of 3 z plus 3 minus, there's the other z, 3z plus 3, the integral of 3 z plus 3. I gotta put dz's. dz. Alright. Because these are the exact same, I think I'm just gonna combine them. Because let's say, for example, I've got x, well, let's say I've got negative x minus x. Well, that's equal to negative 2x. I can combine them. These, while being a little bit longer than x, are still the exact same, so I can combine them in the same way. So let's do that. I wind up with the integral of dz minus 2 integral of 3 over z plus 3 dz. Awesome. Now let's go ahead and factor out that 3 like I said I was going to by the constant multiple rule. So we're left with integral of dz minus, well, if I pull the 3 out, I multiply it by 2. So that's going to give me 6. So I've got 6 integral of 1 over z plus 3 dz. Awesome. So the integral of dz, well, that's just going to be z, and of course plus c, but we're not done. And then we've got, let's try a u substitution here. If my u is equal to z plus 3, then my du must be equal to dz. Well, here's my, well, 1 dz, it's the same. Here's my du, here's my u. Awesome. So I've got z minus 6 integral du over u, which is our natural log. So we've got z minus 6 natural log of the absolute value of u plus c, or z minus the natural log of z plus 3. And I'm bringing that 6 up to the exponent, to the 6th. I guess the absolute values aren't necessary now. Plus c. And we're done. Wow. Well, on the bright side, we're done. Let's go ahead and move into definite integrals. Definite integrals. We've got number 25 to 30 are all definite integrals. So let's start with 25. 25, we've got the integral from 0 to 1 of 2 dx. Alright, with a definite integral, what you're doing is that you're finding the second fundamental theorem of calculus, which states that, let's say we have a graph. We've got this curve. Let's make it a more obvious curve. this going from, let's say, from 0, let's make that 1. So from 0 to 1, from 0 to 1, we've got this plot of space underneath the curve. And what we're doing with the integral is we are finding the area of that. The area underneath the curve is what it's called. Well, that's it visually. Really nothing more to it. Let's go ahead and integrate then. We're just going to integrate in the same way we would, only we're not going to add a plus c. We're going to do something else instead. So if I integrate 2 dx, first of all, I wind up with 2x. So I've got 2x. But now we're going to say on the interval from 0 to 1. So what you're going to do is you're going to plug in, this is called your upper limit, and this is called your lower limit. And we're going to plug them both in for x. So I plug in 2, if I plug in 1 for x, and then we're going to subtract it from the lower limit, minus 2 times 0. Well, 2 times 1 is 2 minus 0. Well, that's going to equal 2. So 2 is your answer. That's why you don't have a plus c, because your answer will only be a constant number. The plus c thing, well, 2 is a c, a constant. I think kind of like the first few, you're just along for the ride until you really see what's going on with it. 25. No, we just did 25. Let's try 26. We've got the integral from -3 to 3 of 8x to the third dx. Oh no, that's to the fifth. Excuse my sloppy handwriting. 8x to the fifth. Well, let's integrate. We're going to add 1. So, and then we're going to divide by that. So we're going to say 8 divided by 6, x to the 6th on the interval from -3 to 3. 8 divided by 6 can reduce to, let's say, equals 4 over 3 x to the 6th on the interval from 3 to -3. And I think something interesting is going to happen here. But let's keep going and see what we get. I'm going to plug in a 3, and I wind up with 4 over 3 x to the, no, it's not x anymore, it's now 3. 3 to the 6th minus 4 over 3 x, it's not x, why did I do that? -3 to the 6th. Alright. My question posed at you guys. Is there a difference between -3 to the 6th? Well, +3 to the 6th and -3 to the 6th. Well, let's prove it. Let's search for my calculator on here. Calculator. Nope. Okay, there it is. So we've got 3. Where's my power button? Caret. Do I have one on this calculator? I've never used this one before. To the power of 6. Nope, that's 36. 3 to the power of 6. Okay, 729. 729. Now let's try -3. 3 negative to the power of 6. 729. They're the exact same. Now, being that you're in calculus, I'm sure you already knew that, but if someone is following along without knowing much calculus or algebra, then anyway, they're both the same number. The same number multiplied by the same number. So it's going to be the same number. Same Same constant minus the same constant. Well, that's going to equal 0, isn't it? If I've got 729 minus 729, that's going to equal 0. Even if it's times 4 over 3 times 4 over 3, it's still the same. It's still going to equal 0. And that's what I wanted to illustrate with this question. Back in college algebra, we learned about even and odd functions. Let's erase this plus 1. We learned that if anything is raised to an odd power, then it's called an odd function. 5 is an odd power. 5 is an odd number. So this is an odd function. Odd function. And if you ever notice that you have an odd function on the interval from, let's call this a, to negative a, then it's going to equal 0 every time. Okay. Some of you might not care too much about that. Let's try 27. We've got the integral from 7 to negative 2 of 8 over the third root of x dx. My first step is to pull out the 8, and I wind up with 8 integral from 7 to negative 2 of 1 over third root x dx. I'm going to pull this up and change it into exponential form. So I have 8 integral 7 to negative 2. Well, from negative 2 to 7 is how you say it. Of x to the negative 1/3 dx. And now let's use our general power rule. Plus 1. Well, that'll give me 2 over 3. And then I have to divide by 2 over 3. Well, that's the same as multiplying by 3 over 2. So I've got 8 on the outside, and I've got 3 over 2 times x to the power of 2 over 3. And that's going to be from negative 2 to 7. And now let's simplify. I can cancel this 2 and this 8. That's going to give me 4. 4 times 3 is 12, so I've got 12x to the 2 over 3 in the interval from negative 2 to 7. I need that calculator back. We've well, let me get one out of my back. Alright, I pulled the calculator out of my backpack because I'm more comfortable using a TI-30 than a calculator I've never used before on my computer. So what I'm going to do is I'm going to plug in the 7 and the negative 2. 12 times 7 to the 2 over 3 minus 12 times negative 2 to the, so let's open that back up, to the 2 over 3. So I wind up with, oh, these parentheses are in the wrong place. So I wind up with, well, let's do this one. I've got 7 to the power of 2 divided by 3. That is 3.65 times 12. That's a large decimal. We've got 43.911. Let's round it to 7. Now let's do the same. We've got negative 2 to the power of 2 divided by 3, which is another decimal, times 12 is negative 19. So we've got negative 19.0, let's round it to 5. Alright. So a negative and a negative I'm going to be adding. So I've got 43.9117 plus 19.05, and that should give me 143.9117 plus 19.05 62.9617. Alright. Not the prettiest answer by any means. Let's go ahead and try number 28. 28. We've got the integral from negative 100 to 100 of x to the 8th plus x to the 4th over x squared dx. And what I'm going to do is I'm going to split the numerator first. So I've got the integral from 100 to negative 100 to 100 of x to the 8th over x squared plus x to the 4th over x squared dx. And these can reduce. If I'm dividing like bases, I subtract the exponents. So 8 minus 2 is 6. 4 minus 2 is 2. So my new integral is the integral from negative 100 to 100 of x to the 6th plus x squared dx. Awesome. Well, let's take note of the fact that this is an even function. When it's an odd function, as we saw up here, when it's an odd function from a to negative a, then it is 0. When it's an even function, though, it's a little bit different. When it's an even function, what you do is you can make this, you can say 0, and you can put a 2 there. I'll prove that in another video because 100 is just a very large number to be working with. So I'll use a different example. But let's just do the integral. So now my new integral is 2, integral from 0 to 100 of x to the 6th plus x squared dx. And let's integrate. So I'm going to add 1, So I've got 2, and it's no longer an integral. 2, 1 over 7 times x to the 7th plus 1 over 3rd times x to the 3rd from 0 to 100. So let's go ahead and plug in 100. We've got 2, 1 over 7 times 100 to the 7th plus 1 over 3 times 100 to the 3rd, and is going to be minus, if I plug in 0 for my x's, I just get 0, minus 0. So that would make this our answer. And I think you guys know how to plug that in your calculator, so I'm just going to leave that because it's going to be so many zeros. You get the idea of the integral, though. On your test, I really hope your professor won't do that to you. That's absolutely cruel. Number 29, we've got the integral from 1 to 6 of e to the power of 1 minus t dt. Okay. What we are going to do is, let's split. No, we don't even have to do that. It's much easier. I was going to say let's split the exponent and separate it, but it's easier. This is our e to the u du equals e to the u thing. So let's get rid of that. Let's say u equals 1 minus t. Therefore du equals negative dt. So we've got to put in a negative sign there and a negative sign there to balance it. So we've got the integral, the negative integral of e to the u du. That's equal to negative e to the u from 1 to 6. And let's plug in our u. We get 1 minus t. So equals negative e to the 1 minus t from 1 to 6. And then we've got negative e to the 1 minus 6 is negative 5. So e to the negative 5. And we've got minus negative e to the power of 1 minus 1 is 0. Alright. Anything to the 0 power is automatically 1. So we've got a negative 1, it's going to be because of that negative sign, and a negative sign out there, so it's plus 1. And I'm going to bring this down to the denominator. So finally I've got negative 1 over e to the 5th plus 1. And we can end that one there. Now for number 30, we've got a really long one. Number 30. We've got the integral from 1 to 3 of 96x to the 7th plus 102x minus 3 over 4x to the 8th plus 17x squared minus x dx. Wow. This looks absolutely terrifying. The only pattern that I've noticed is that all of the degrees of the top are exactly 1 less than the degrees of the bottom. I bet you didn't know this, but there's an imaginary x to the 0 power right there. X to the first, x to the 0. And the reason we don't show it is because anything to the 0 power, as we set up there, is immediately 1. So I'll just leave that there. What I'm going to do is I'm going to change colors first, and I'm going to just follow the same pattern this entire practice test has been following. Let the denominator be u. So I'm going to just, hope that this works. U equals, because I'm on my test and I've almost got 100% from what I can tell. Well, let's pretend I'm taking the test and I'm u, Let's take the derivative, end that narrative. Let's put the 8 down. We've got 32 to the 7th plus 34x minus 1. Okay. Is there any way I can manipulate these numbers to look like these numbers? Looking at the difference, I've got a 1 here and I've got a 3 here. I'm just going to go for a shot in the dark and say if I multiply everything by 3, then I'll have that. Well, 32 times 3 is 96. Okay. 34 times 3 is 102. Okay. Our logic lines up. So if we want to make this du, we should put a dx here. If we want to make this du, we've just got to put a 3. No, if we want to make this du, we've just got to put a 3. A 1/3. What am I doing? I am trying to make this number match up with this number. In order to make this one match up with that one, I have to multiply everything by 1/3. So that's what I'm going to do. I'm going to place a 1/3 right here. And if I place a 1/3 there, to reduce it, to get to du, then I have to put a 3 on the outside to balance it. So that's what we're doing. Now that it's balanced, we've got the 1/3. That is now du, and this is u. So we've got a 3 integral from 1 to 3 of du over u. And that is our natural log. So we've got 3 natural log of u plus c. No plus c. On the interval from 1 to 3. And let's go ahead and back substitute. So we've got 3 ln of 4x to the 8th plus 17x squared minus x from 1 to 3. And let's go ahead and plug in our numbers. We've got 3 ln of 4 3 to the 8th plus 17 3 squared minus 3 minus 3 ln absolute value of 4 times 1 to the 8th is, well, 1, plus 1 squared is 17. Now 17 times 1 squared is 17, minus 1. Okay, that's going to be 20, 3 ln 20, and then we can just simplify one more time, 3 ln because these are the same base, I'm going to use a property of logs to bring subtraction into division. So I've got 4 times 3 to the 8th plus 17 times 3 squared minus 3 over 20. And we're done. Okay. Thank you for watching, everybody. I hope it wasn't as... I hope you learned something. Let's just say that. This has been Terry the Tutor, and I'll calculate later.